Hi, Mr. Cole here, and today's topic is going to be integer exponents. And our goal for today is we're going to, first of all, simplify zero and negative exponents. Then we're going to use it to evaluate expressions with zero and negative exponents. Our standards for today is going to be number sense 2.0, and our vocabulary for today is zero exponent, and any non-zero number raised to the zero power is 1. So anything that you see, 3 to 0 power, x to 0 power, it's always going to be 1. The only thing that's not going to be 1 is going to be 0 to 0 power. So that's not 1 at all. Okay. Next one, negative exponent. Any non-zero number raised to the negative exponent is equal to 1 divided by the base and the power. And that seems like a whole lot of mumbo-jumbo thingy, but basically it becomes a fraction with 1 above it and the same base and the same exponent. And we'll explore this when we go along. Alright, so let's first simplify zero and negative exponents. So the first thing we're going to do here is whenever you see a negative exponent, you have to understand that it's going to be a fraction. It's going to be a fraction with a 1 on top of it. So we're going to go ahead and take this and we're going to rewrite it. And when you rewrite it, you're just going to rewrite it with this exact same base and exponent, but without the negative. The negative is basically just telling you that it's going to be a fraction with the same base and same exponent. And that's going to give you 1, and then that's going to be 3 times 3. And evaluated is going to be, or simplified, 1/9. Okay? So let's try the next one. Now going back with our vocabulary, 5 to the 0 power is going to be just 1. So anything to the 0 power, that's an easy one. We're just going to go ahead and say it's 1. Alright, let's go ahead and work on this one. Now, if you notice, there's a negative here, and we're only centering on that negative exponent. If you look here, negative 3, so we're going to go ahead and automatically know that it's going to be a fraction. Here's your 1, and you're going to take the same exact base, and you're going to go ahead and put that exponent there without that negative. So let's rewrite it out. You now have 1, and that's going to be negative 2, negative 2, negative 2, 3 times, because that's what it's telling me to do. Then you're going to have 1, and then it's going to be negative 2 times negative 2, which is positive 4. Positive 4 times negative 2 is going to give you negative 8. And that's my answer on this part. Okay? So once we're done here, the main question that you should be able to figure out is, how would you set up a negative exponent? Okay? And we've covered this in here. Alright, so now, what happens if we need to evaluate expressions that have zeros and negative exponents? Well, let's go ahead and just follow this. The first thing we're going to do is we're going to substitute for the variable, okay? And then secondly, we're going to go ahead and create that the fraction with the 1 on top, and then finally we're going to go ahead and simplify. So let's go ahead and work on this one. So here we have p to the negative 3 power, and we notice that p is going to be 4. So all we're going to do is we're going to just substitute there. What I want you to make sure that you're doing here is that you are, when you're placing a 4 here, make sure you put a parentheses here, and then your negative 3. Okay? And again, you want to put this in parentheses because you are taking this entire term right here to that negative 3rd power. Now we're going to go ahead and set it up as how we normally would with a negative exponent. So that's 1, that's our negative right here, and then it's going to be 4 to the 3rd power. If I were to expand that out, we have 4, 4, 4, and that's going to give us 1, and I think 16 times 4 is 64. Okay? So that is our basic steps on how to solve this particular question here with the unknown variable here. Okay? So now, let's go ahead and make it a little bit harder. So here I have 8 times the quantity, 8 times a to the negative 2 power, b to 0. So here we can kind of do a little bit of shortcutting. No matter what we do, we're going to first of all substitute. So here, let's go and rewrite 8. A is going to be negative 2, and again, you see how important that parentheses is right here? And then again, we have b, which is going to be 6, and that's 6 to the 0 power. So let's solve it out, and again, your exponents, your exponents come first before you multiply. So it's still going to be 8. That's going to be times 1, because that's our negative 2, and then it's 2 to the 2nd power, because that's 2, negative 2 to the 2nd power, and then here it's going to be 6 to the 0 power, which is times 1. And then let's continue on here. So I'm going to have 8 times 1, and then it's negative 2 times negative 2, which is going to give us 4, and then times 1, and then continue on. So this, again, here, we're just going to go ahead and create fractions over here. And if we create fractions, it'll be 8 times 1 times 1, which is 8. 1 times 4 times 4, which is 4. And our answer is going to be simplified to just 2. All right. So, again, we've just evaluated a couple of expressions. The question that I'm going to ask here is, and you should be able to answer is, what is the answer to any number raised to 0 power? Make sure that number is a non-zero number, okay? So you should be able to know what that answer is, just by what we've done so far. All right, so let's go ahead and do a little bit other types of simplifying. Now, this time we're going to simplify with a variable. So here we have 3a to the negative 2 power. Just rewrite it out. So you now have 3 times, and then that's going to be 1, because we know that that's a negative 2, and then it's 8 to the second power. Simplify out, so add that 1 right here. So your answer is going to be 3a to the second power. Okay? All right, let's look at this one. Now, what happens when you see a negative on the bottom here? Well, a very simple thing happens. This basically just becomes the flip version of what it is. So this looks like 7. If I were to rewrite it out, it would look like 7 over, and then this is the weird part. It looks like 1 r to the second power. And let's go ahead and just explore this part. If I were to rewrite this, that would look like 7 divided by 1 to the r second. And in reality, if you are dividing fractions, that's actually 7 times r to the second power over 1. To finish this up, you now have 7 r to the second power over 1, or just 7r squared. Now, and I want you to follow along with what I'm looking at here. This just went from the bottom, the denominator, to the numerator, and it became a positive exponent. So another way you can look at this is, and the shortcut to this is, r to the negative 2 power is basically just a flip version. The opposite exponent and the numerator. And that's it. So let's take this one and practice with it. So first off, a to the negative 7 power means we have 1 over a to the 7 power, which means we can just put that down here. C3 is still going to be on the bottom. And then we're going to take this d, negative 4, and what we learned from here is we're just going to place it up, because of what we kind of established here. And then don't forget, we still have our b to the second power. So just looking at this, because you have negative exponents on the denominator, that flips it up. When you have negative exponents on the numerator, that flips it down. So that's something I want you to keep in mind, okay? All right, so let's go ahead and recap. Okay, so we have a couple of things we need to recap. So first of all, we're going to recap negative exponents. The first thing we need to do is place it into a fraction format, and 1 is going to be on the top, and then it becomes your base and just the exponent. Okay, no negative, just the exponent. Then we're going to simplify that. What happens when you have a 0 exponent? Well, anything that is non-zero to the 0 power, any number, could also be a letter, because a letter would stand for a number or variable. It's always going to be 1, and then you can simplify after that. Now, the new thing that we're going to really take on is when you have a negative exponent in that denominator area. So what happens is that denominator area becomes the same base. So like what we had learned in the previous slide, same base, you just flip it up, and then it has the opposite exponent, which means if it was a negative on the bottom, it's now a positive on the top. And then after that, you're going to go ahead and simplify as well. Okay? So judging from the previous slide and this slide, what if there is a negative exponent in the denominator? You should know how to work on it from that point. Okay? So if you'd like to see more videos, go to www.youtube.com/user/tycodad, And one final thing that I wanted to add is if you needed more practice, on page 397, all the odd problems of your textbook have answers in the back. So if you want to just kind of practice a little bit, you'll see how it kind of works out. All right? Thanks for watching.